try a different kind of one. So it says, a farmer has 360 yards of fence to enclose a rectangular pasture. If he uses a riverbank to border one side of the pasture, he can enclose 16,000 square yards of land. What will the dimensions of the pasture be then? And so when I say dimensions, we're saying like what will the width and the length be? Okay, so the thing to keep in mind here is that our rectangular pasture, one of the sides, one of the lengths we could say, is going to be water, right? The river. And so we're going to have two widths and only one length in terms of our fence. So perimeter usually 2W plus 2L, but since one of our lengths is going to be the river, the perimeter in this case is just going to be 2W plus L. And when I say perimeter, I just mean the part of the perimeter that we're using fence for. Because technically the perimeter of the whole thing would include this top part of the rectangle. And then the area of a rectangle, right, is just the width times the length. So we have these two equations here. And so let's plug in the values that we know. We know that we only have 360 yards of fence, right? So this one right here is going to be 360 equals 2W plus L, right? Okay, and then the area we know is going to be 16,000. Equal to W times L. So what we can do here is we can just do a substitution and then solve, right? Solve for W, solve for L. So over here we're going to do a substitution. I'll just minus 2W on both sides. So, I'll bring that down over here. We're going to get, if we minus 2W both sides, we're going to get 360 minus 2W. It's equal to L, right? Okay, so now we can substitute this thing, right? Since that's equal to L, we can substitute it right here. So that means if we rewrite it into this equation, these equations are kind of stacking on top of each other. If we rewrite it in there, we're going to get 16,000 equals to W times L, which we know is 360 minus 2W. Okay, so now let's just distribute the W's, right, or this W right here. So I'll write it a little bit more to the left. So W times 360 is just 360W. And then W times negative 2W is minus 2W squared. Okay, so now we're just dealing with a quadratic, equation that has only W in it, so we can solve for W here, right? So, we could set it equal to 0, right? So let's move, let's go ahead and move everything over to the left. Okay, and so now if you want, we could divide everything by 2. We could do the quadratic formula. There's a few ways to solve this from here. So really quick, let's just divide everything by 2. We're going to get W squared minus 180W. Plus 8,000, right? Equals 0, right? 0 over 2 is just 0. Okay, so now we have this, quadratic equation. We can solve with the quadratic formula. Or we could try to factor it. I mean, if you're good at factoring, you might have already noticed that 8,000 is divisible by 80 and 100, right? 80 times 100 is 8,000. And if you add those two up, you get 180, right? So that is how you would factor this. Or you could just do the quadratic formula. Or there's like the X method for factoring. You could try that too. So we're going to get, and so we're trying to get a minus over here, right? And a positive over there, so we'll do 2 minuses. Okay, so we have W minus 80 times W minus 100 equals 0. And then, we just basically say each of these factors is equal to 0 now. So we're gonna get, and then solve for W, right? You guys might have already seen the video on factoring and stuff, so this is just gonna give us W equals 80 and W equals 100. And so you might be noticing, like, okay, wait, we have two width values, and so a lot of times with these problems, one will come out positive, one will come out negative. And so obviously you can't have a negative width, right? Width is a length. You can't have a negative length, that just doesn't exist. So you only keep the positive one and you continue with the problem. But for this one, we just have two possible widths that'll solve our problem. So we'll just use both of them. Remember that W could equal 80 or 100. And then so if we go back to the original, back up here, remember that length is 360 minus 2W, right? So let's write that over here. Let's make the line there. Okay, so we plug in 80, we get 360 minus 160. And we get L equal to 200, right? And so that's going to mean that if we have a width of 80 and a length of 200, then that will actually be the solution to our problem. That could be the dimensions of our rectangle. But let's say the width was 100, right? Oh, and so yeah, really quick. Okay, so now we're going to do 360 minus 2 times 100. So that's 360 minus 200. That's going to be 160, right? So this is the other possible dimensions. With a width of 100 and a length of 160. And so that could be another possible answer to this problem. So either of them, or sort of both of them, are solutions. Okay, let's try another similar one. This one's a little bit easier. And so I want you to try this one on your own. So it says you have a rectangle with an area of 56 and a perimeter of 36. And what are the dimensions of the rectangle, right? So when I say dimensions again, that's like what is the width, what is the length? And so try this one on your own, pause the video, give it a try, and then we'll talk about the answer in a minute. Okay, so hopefully you gave that problem a try. And so remember, area is width times length, right? Perimeter is 2 width plus 2 length. And so basically just set up the equation. So our area is 56 equals width times length. Perimeter was 36 equals 2 width times 2 length. And over here you can simplify this, divide everything by 2. You get 18 equals W plus L. Then you could just solve for like W, say W equals 18 minus L. And then, substitute that in for this W. You get a quadratic formula or quadratic equation. That one should be easy to factor this time. Hopefully you found that easier to factor. And you should get that the answers are either going to be the width is 4 and the length is 14, or the width is 14 and the length is 4, right? Same rectangle basically. So hopefully you got the same answers.